Hi, today I'm gonna have a demonstration of the media scraper of this case study right here. The media scraper. First, I'm gonna introduce the project, what it is about, the tech stack, and what problem and what solution I have chosen to solve this study case. First, this is the project of mine. I have a GitHub link to it. I will send you this later. Uh, So this is a media scraper. I will try to scrape media from web URL, scrape like image and video. I will try to handle 5,000 concurrent API requests with a limit resource. Resource is 1 CPU and 1 gigagram. So the text that I'm going to use is backend, Node.js for backend and React for frontend. Uh, Moreover, database I will use PostgreSQL and use Redis for queue, and then Dockerize with Dockers. So the problem is here how to handle 5,000 API requests with a limit resource is 1 CPU and 1 gigagram. So I cannot try to run the operation 5,000 operation in the cost, so I have to use a architecture called producer consumer pattern, or call it event driven architecture. What is do is I will have the backend at the API will handle the request, the incoming request, then immediately send the task create and send the task to a queue that will be handled by Redis. So the API will always return a 202 started code. Then quite a task will be pushed into a queue using Redis via pull MQ used for queue built by Redis before not yet. Uh, from your mission, I'm using FastDivide as a backend framework for this. So after is pushing the tasks into a queue, we will use worker to work a backup job to perform the scraping operator. Then it will store the result in the database using Postgres, and then we able to grab the data, media, and show on the UI. The case study requirement, as I said, is one core of CPU. We will have 1 gigagram to handle 5,000 API requests at the same time. So, uh, we try to run the project first. And we use Docker Compose up to run four components. First is the database, the Redis for queue, the backend, and the frontend with only one command here. I will check the previous compose up. Okay, now I'm running it. We'll wait a few seconds for the backend to run. I'll check the backend log. Okay, seems like this is running right now. You can have the health check for it, but won't be necessary. Uh, so first, I will show you the container start for this. For this, the Docker Compose file, I will divide the one core CPU into 3 components. First is the Postgres. We will use about 0.3% CPU for it, 0.1 for the Redis, and the remaining is 0.6 for the backend. So the memory of 1 gigabyte is 1024 millibyte megabyte for this. So I divide it like this, 90 megabyte for this and 280 megabyte for the database. Front-end is another component that not restricted in the requirements, so I will have it freely according to the client front-end. Okay, now I will show you the scraping API first. Mm, it's still recording. Okay. I will show you the UI first. Uh, Local host. This is the front end. The simple UI for the media scraper right here. I have put the scraping API to here. Also, you can call it with Postman or right here. So I try to call the API with Postman first. It will be the endpoint right here, and the body request will be like this. And plus, okay, I will try it for this endpoint first. Is a URL to this. Okay, now I try to run it. Okay, and I will open the database for this too. We have two table. The first one is a scraping task that store the task. Check the status if whether is it fail, pending, or complete, and the media result which contain media URL, the type, and the task ID mapped to the scraping task. So okay, I will try to order get the latest first. Order by the descending. Okay, so the latest will be shown on top. I will try to run this. Okay, the request is queue for scrapping with one task ID about 1 minute. Here we can see with this URL get to media item are found right here. So I will refresh this. Here we have to unblast about 49 minutes, about a minute before. We can so check on the UI here, refresh with the blast right here. It's the same URL of this. Yes, the same URL. Or we can use on this too. I have some test UI for this, like the here Stack Overflow. Okay, here for scrapping, and here a lot for this. Request complete. And check the media. 83. Estimate refresh. Taking a little time. And it's not running. Fail. Okay, the link fail is might be resolved by oh, because I passed the wrong one. Okay, let's do it again. Okay, now Okay, it's work now. Now it's correct now. Here. The reason why it's fair because I paste 2 times, so the URL is appending others, so it failed. So the battery works well, and the media is here. Next is the DB schema. So I have the schema for 2 table, the scrapping tab to store tab for the worker to work with, an ID and URL of the web page and the status, and a media result. Have the media type and media URL mapping to the scrapping tab, VA task ID right here. Okay, the task created that you see in this, and media scrap it here, this one. So the front end UI is this one. This is the UI. Here we can set on, but I have a pagination right here with the page one. Here's the pagination. Okay, now to the type video. I have type of video right here. Or we try to search the text by the media URL. I try Docker's set. It will only Docker's image, Docker video right here, or set by image. If I have the image about Docker, or both. If we choose already, it will have both the image and video about Docker or GitHub. Yes, GitHub. It will have right here. Okay. So next I will try to run a load test with 5,000 API requests in 60 seconds. Average of about 90 API requests per millisecond. For this load test, I will use burst test, 50 requests in 60 seconds. The target is 33 requests per second, and each request will have 10 URL to scrap. So I try to run. So we try to run this load test script. How to run test. Here, load testing. I will try to run it again, and we run burst mode. Before that, I will try to have a Docker stat right here to check how much is running. This is the menu sec. As you can see, the backend processor and Redis use in 1 gigabyte of RAM right here. Okay, so I will start trying this. So it's running now, and you can see the backend CPU sec is spiked up. Menu sec is used right here. So 500 requests are made, 2000. You can see the backend log is running, and the database is running too. Yeah, it is running 57 minutes here. It's pending because it's pending for the worker to scrap. It still run well. Okay, now the 5,000 requests sent into the server. Although it's done, but in the background, the worker is still running the task right here. Okay, so with this setup, it will have 99% of success rate. There's still some cases that fail, but that is because that website have like a restrict about security or not all the timeout that this server call it. So it's still okay for this study case. So it's described the data right here, and you still can use it to check. Here's this media dash graph from list of API. For more information, you can click and see the document I have here about backend structure, configuration, and project summary. Okay, thank you for watching.